Hi everyone, we are going to talk about how to solve rational equations. Remember, rational means fractional, so equations with fractions in them. Now, what we should always do first is check to see with our calculator, what is the answer going to be? That way we know at the end, are we getting the right answer? And what we're going to do is we're going to put the left side in y1 and the right side in y2. I already have that up in my calculator. And when I go and look at the graph, I can see that there's one intersection, so there's one solution. Now you can do second trace choice 5, scroll over where the point of intersection is, and you can hit enter 3 times, and I'll see that my intersection is 3. Or I can go to the table, and at 3, I'll see that my y values match. So I already know that I should get an answer of 3. Let's make sure at the end, after doing it algebraically, am I getting 3 as well? Now, to actually solve this algebraically, you're going to look at the equation and you're going to think, what can I possibly do to this? Well, what we can do is we know how to add and subtract fractions. So what we can do is combine my two fractions on the left-hand side. Now we know that in order to combine fractions, we need to have an LCD. So think about what the LCD in this problem is between 2, 3, and 6. The least common denominator would be 6. So what's going to happen is I'm going to write the whole thing out, and we're going to multiply by what's missing. I have x over, that's not an x over 2 minus 2/3 equals 5 over 6. And I want to get all my denominators to be 6. So in order to get my first denominator to be 6, I have a 2. I need to multiply by 3 over 3. If I have a denominator of 3, I need to multiply by 2 over 2. What this is going to do is make all my denominators 6. So now I have 3x over 6 minus 4 over 6 equals 5 over 6. And if you notice, now what I can do is combine my two fractions, which is pretty great. Now I have 3x minus 4 over 6 equals 5 over 6. And the question is, how do I get the left fraction to look like the right fraction? And you might notice that the denominator is already the same. So really, the only thing that's different about these two fractions are the numerators. So because the denominators are the same, we no longer have to worry about getting the denominators the same, which means we could kind of ignore them, and now we could get a nice equation of just trying to get the numerators equal to each other. This is an equation we can actually solve. We can add the 4 to both sides, and we have 3x equals 9. And if we divide by 3, we get x equals 3, which was supposed to be our answer in the first place. So as a recap, what we did is that we combined the two fractions on the left-hand side. We have fraction equals fraction. Because the denominators are the same, we only worry about getting the numerators to be equal. We drop the denominators because they're already the same. We don't care about them anymore. Let's try again with the second one. First, we're going to check it with our calculator. So I put the left side of the equation in y1, and I put the right side of the equation in y2. And you should really be doing this with your calculator as well and following along. If you take a look at the graph, the thing about rational equations is that their graphs look very complicated, and you're going to learn more about that in pre-calc next year. But if you can see on the right-hand side, it kind of does look like the blue and the red lines are intersecting. So if you do second trace intersect, you can scroll over to maybe about, I want to say this is kind of where they intersect. You can hit enter 3 times and you'll get an intersection of 4. You can go to the table and you could see that at x equals 4, the y values are the same. I don't really see any other points of intersection. So I think that my answer is going to be 4. Well, actually, I know my answer is going to be 4. I need to see why it's 4 algebraically. You're going to ask yourself, what do all 3 denominators have in common? My LCD, they all have a 3, they all have an x. We rewrite the problem, and our goal is to combine these 2 fractions. So I'm going to write it as 1 over x minus 1/3 equals negative 1 over 3x. And we're going to multiply by what's missing. The first denominator has an x, it's missing the 3. The second denominator has a 3, it's missing the x. The last denominator has a 3, has the x, leave it alone. We're going to rewrite this as 3 over 3x minus x over 3x equals negative 1 over 3x. By the way, guys, when the negative is in a fraction, it does not matter if the negative's out front, up top, or in the denominator. It's all the same thing. Now, finally, we can combine these 2 fractions, and we can rewrite them as 3 minus x over 3x equals negative 1 over 3x. We have fraction equals fraction, and notice how the denominators are the same. Our only goal now is to make the numerators the same. We want the denominators to be equal and the numerators to be equal. We can forget about the denominators and now look at the equation in the numerator. I have 3 minus x equals negative 1. This is something that we can solve. We can add 1 to both sides, and we would get 4 minus x equals 0. If we add x to both sides, and of course there's multiple ways to solve this, we get that x is equal to 4. Great. Now let's try one more, because frequently this does come up as a multiple choice question, and when it happens, we can do this very easily. So all of this will go in y1, and all of this will go in y2. What we're going to do is you can take a look at the graph, and unfortunately, if you do graph this equation, it looks extremely messy. So sometimes instead of looking at the graph, it's easier just to look at these points. So we're going to check out 0 and 2 in the calculator, and we're going to see, does it make the solutions match? If we look at it, at 0, we have that our y values don't match. And at 2, we have that the y values do not match either. Error does not count as an answer. Really important. So if 0 doesn't work, and if 2 doesn't work, well, our only answer then is nothing works. This is called your empty set, and it's what happens when you have no solution. Sometimes we will actually get no solutions when we have weird equations such as fractionals, or we're going to see radicals involved. There are certain values that won't work out with the equation. Can you figure out why 0 and 2 don't work for this problem? Maybe you realized it, but 0 and 2 actually make these answers undefined. Look what happens if you plug in 2. You get 5 over 2 minus 2, which is 0. That's undefined. That's what's causing the error. And look what happens if you plug 0 in here. 4 over 0 would be undefined. So we're going to check out in class what happens when we get answers that actually make things undefined. We're going to have to reject them. Anyway, our steps for solving rational equations in general is you want to figure out the LCD of the problem. You want to multiply each piece by what is missing in order to get to that LCD. Cross out the denominators once they are equal only, and you're going to solve the resulting equation. Just be careful, you have to check your answers. In class, we're going to see that sometimes you do have to reject answers because they make the fractions undefined. And that's all for this video. Hope